everyone, my name is Tor, Calculator, and I hope you're excited to go back into history and learn about one of the biggest maths controversies ever, the beginning of calculus.
I, Isaac Newton, always found it simple to calculate the average slope of a curve using 2 points, rise over run. However, it befuddled me as to why there was no way to calculate the gradient of an exact point on the curve, and hence, I created the method of fluxion,
which is known by the general population as differential calculus, created by me, Gottfried Leibniz. Guys, look, it doesn't matter. They're both representations of the same thing. But, to be honest, dy dx or f-x is the one that most people use. Exactly. Thank you, Tor. As my former teacher was explaining mathematics, the light turned on, and I realized that tangents were merely a ratio between the ordinate and the abscissa.
a pretentious way of saying x and y. However, we can simplify this using a curve. If we take the point x and x plus h as x coordinates with the indefinite distance h in between, I decided to use the gradient formula to develop this, and if we substitute in a random equation, this piece has parabolic speed, which if we substitute x and x plus h into, we get the formula for how quickly I was changing my speed, which is how much it increases or decreases, which is the gradient, also known as the derivative. The shorthand version is a type of rearranging. If we pretend to pick up the index, leaving it minus 1, and move it to the front, we can find the same derivative. But that's not all. If one has the rate of change and need to find the amount of the object, they just have to do it backwards. To find what I have called the primitive function, we use the symbol of an elongated s from the word somma. To find an integral, we see that the area under the curve is just the addition of all the ordinates to the abscissa. The proof is this. Imagine rectangles. However, what if the rectangles were smaller? There would be less excess. However, what if the rectangles were even smaller? Infinitely small, in fact. Their answer would be exactly accurate.
And therefore, I have proven the existence of mathematics based on infinite values. Whilst Newton and Leibniz spent the rest of their lives fighting over who was the original creator of calculus, they both independently discovered this integral part of maths. Until next time.